Hello and welcome to Plant CEO. In today's episode, I'm super excited to introduce Leonard Lerer, the founder of Back of the Yard Algae Sciences. Welcome, Leonard.
Thank you very much. It's really an honor to be on your webcast.
Yeah, I'm excited because you're going to give us an exclusive look behind your lab and we'll get to meet some of your scientists shortly.
Yeah, well, it's not exclusive because the one thing that we're totally committed to is transparency. People can come, they can visit. We have very close interaction with the local community and the greater Chicago and Midwest science and public community.
So is this a video exclusive, or it's not something? It's not an exclusive as in
Well, we're not very well known. So as far as video goes, we're not exactly publicity hounds. So
okay, well,
it is an honor to be here.
Okay, awesome. How did you first of all come up with the name?
Well, we're situated in the back of the yards. It's the back of the old Chicago stockyards. This is a very, very historical place for anybody who's interested in the history of industrial food. This is basically where industrial meat was invented, in the few square miles that surround this facility. Literally, I would say hundreds of millions of animals were slaughtered within a perimeter of a few kilometers of here. And we're sitting in what was an old pork processing plant, which I always find quite ironical because I'll show you a lab where we're busy growing cruelty-free meat in the very site which has the karma of literally millions and millions of 100 years of pork processing in this building.
Wow.
So we are back of the yards because we're in the back of the yards.
Right. And when did that pork processing company close down?
Well, essentially, the decline of the industrial meat industry in Chicago started in the 1970s. And this particular plant lasted until 2007, when it was abruptly closed due to a merger and moved to Indiana. And what's very interesting is that the building was supposed to be demolished. And John Edel, who is the visionary, and I'll show you his anaerobic digester, took this building and he converted it essentially into what he believed would be an incubator for local food, completely sustainable and devoted to the circular economy. And we'll see aspects of that when we do our tour.
So, can you start by telling me basically why algae? You know, it's got a number of benefits from what I hear, but it'd be great to hear it from you.
Algae are basically the fundamental foundation of the planet's food chain. They process most of our CO2, and they feed the foundation of the food chain. And to be very succinct about it, essentially all we're doing is we're trying to flatten the food pyramid. In other words, bring us back to using resources which do not require further processing, either by animals or by humans. And for us, algae are essentially a tool to achieve that. We call it Back of the Yards Algae Sciences, but essentially we're a circular economy, sustainable industrial biotechnology company.
What was interesting when we spoke the first time is how you actually came across the protein element when you made a discovery back in Paris. Can you just take me back to that point again?
Well, essentially, I am a recent convert to plant-based food, alternative proteins, cruelty-free meat, etc. What happened was that I had originally invested in a company which was doing something to produce algae, and they had accidentally discovered a way of making a blue food colorant. This is natural blue as opposed to chemical blue. And there is a growing demand to move to natural colors. And through a whole series of serendipitous events, I essentially decided to build up the industrialization of the blue colorant. And here it is. Okay, this is called phycocyanin.
Can we get it closer? Yeah, it's very nice. Okay. Yeah,
a beautiful blue. And I was here essentially to sell this colorant on an industrial scale to Mars. to Mars Candy Company for M&Ms.
Right.
And I was looking for some cheap space to work on the upscale. And I found this building where it was really cheap. And this little corner which we're sitting in is where back of the Yards Algae Sciences started. It started in about 10 square meters. And what happened, to cut a long story short, is that as I got started with making blue colorant, I discovered that there was a thing called alternative proteins, plant-based meat. And so we started to work on that. And then I discovered that there were biostimulation aspects of the blue colorant in agriculture. And so I just arrived at the time when, number one, the plant-based meat boom was beginning. Number two, vertical farming, indoor farming was starting. And then the last terrible event that happened to us, I suppose, in terms of having to spend a lot of money on development, as you'll see, is this growing interest in cellular agriculture, cell-based meat, cell-based fish. So essentially, I got caught in this whole whirlwind of innovation, food innovation, and I was in the right place at the right time. And that's basically what I wanted to show you. I was in the right place at the right time, I would say, to develop new products, new ideas, new innovations. And hopefully in a few years, we'll be in the right place in order to see these things spread, truly industrialized.
Yeah. So it's funny how you discovered it, looking at the extract of the blue color. When I think of M&Ms, it's normally yellow and green, yellow and red, I think. And sometimes they have the blue one that comes out in a special edition. Is that because it's hard, like the chemical process is just not very nice to make that blue color? And what you were saying is to get it as a plant-based form is quite a tricky thing to do.
The chemical blue, the blue dye, Lake Blue, Blue One, costs $4 a kilo. $4. Okay, it's a chemical. It's cheap. This particular product sells, I would say, at around $200 a kilo.
And do you think that price will come down eventually?
Well, that's what our mission was,
right?
And, it remains. And we're about to start actually industrializing it on a large scale at our plant in Utah.
Okay.
Because this is much too small. Right. And the whole thing is that Mars, for example, has committed itself to move to natural colors. Yeah. There's a strong global consumer and regulatory movement against artificial colors.
Yeah.
There are claims of connections with autism and all sorts of things.
Oh, wow.
The reason that if you buy Mars, for example, did launch a natural blue M&M, but because of the pricing, there were very few blues in it, and the color of the blue wasn't that good. So Mars stopped. But what's very interesting is, and I think it's actually applicable to our discussion on plant-based meat, on cellular agriculture, is essentially that Mars has committed itself to natural colors.
And if you look at the plant-based as well, like the chocolate, obviously moving away from dairy, did they tell you about that side? Are they looking at that too?
Yes, I understand that they are moving towards sustainable, cruelty-free ingredients.
Awesome.
But if you just take the blue color alone, if Mars were to move to natural blue tomorrow, you would need approximately 5 times the world production of this particular natural color just for M&Ms alone.
Right. Yeah.
It's incredible. So our whole philosophy is we'd like to see a better world. We'd like to see animal cruelty is not good for ourselves, clearly. Eating food that's not environmentally sustainable is not good for the planet, et cetera, et cetera. But our view is the only way this is going to happen is if people work on making these processes industrial, scalable.
Yeah. Scalable.
And the biggest example is undoubtedly that of lab-grown meat, cellular agriculture of meat. The first the first burger, which was made cruelty-free without killing an animal, was made in 2013 by Mark Post and our friends at Mosa Meats. okay, funded by Sergey Brin, etc. We are now in 2021 almost, and you cannot go get a cruelty-free burger in the supermarket. Okay, I'm talking about real meat burger. And the question which I keep asking myself, and I asked it about plant-based meat, I asked it about burgers made, grown out of cells, fish, etc., 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 is why? Why, after almost 8 years, can we not get these things available to the public? And our mission essentially is to bring sustainable food that is equitable, accessible, preferably edible, which is always a good idea, tasty. But to get that not to specifically the vegan community or the plant-based community or the affluent people or people who are ideologically driven to do X, Y, Z, but rather people who are not so much flexitarian, but more reducitarian, okay? And our whole philosophy is essentially a reducitarian philosophy, which is the circular economy. Now I'm giving you my ideological talk.
Yeah, that's fantastic. And so talk to me now about the protein side. We covered the color. How much, like, I don't know if you can compare protein levels that you would extract, like if, you know, or the process of like from 100 grams of algae, how much protein can you get out of that?
Okay, firstly, algae are very rich in protein. Spirulina, and I'll show you our spirulina cultures, etc. We're talking about 60% protein, high quality protein, all the amino acids you need, etc. Very important when you're going to use it to grow cells, etc. Okay, so that's the one side. So algae is a good source of protein. The problem is it's largely doesn't taste good. So most of our work is around making it taste good. And if you look on our Instagram, you'll see that we are now capable of making algae-based plant meat, which tastes as good as, if not better, than some of the big brands, you know, Beyond and this kind of thing. The questions which we are facing is that's not good enough. We want to go even further. We want to make sure that this is a truly sustainable ingredient, that it tastes good. It tastes really good. I'm not saying it has to taste like meat, okay? It just has to taste good. And so we are basically very much focused now on the hybrid food. Okay. In other words, plant-based protein. And I think the whole issue of protein is very interesting because it's essentially a consumer trend. It's meaningless. We all get enough protein, okay? You're a vegan, correct?
Yeah.
Look at you, you're so healthy. You get enough protein, okay? Yeah. I'm sure you don't obsess every day about the protein content of it. So I see, essentially, this is a trend, and this trend will die out, okay? What we need to make is nutritious food. Nutritious food has protein, has carbohydrates, has fats, etc. You know, I think what we're basically saying, if you're going to industrialize plant-based foods, if you're going to industrialize cruelty-free foods, you have to talk about food. Yeah, and so you're going to see very sophisticated science here, but we're farmers, we're industrial biotech people. We're there to make it in a big scale, because the big changes that occur are not going to be when the large food companies incorporate these ingredients into their food. That's when the big change occurs, you know. And that we still have a long way to go.
And you said that you're a farmer. One of the uses that you could have is a biostimulant for plants, for the growth factor in plants. Can you tell me a little bit more about that?
Yes, and on the tour, I'll show you some of the work we're doing there in the labs. At the moment, let me work backwards. At the moment, our biostimulant, which is a version of this blue you've seen, I mean, it's a different formulation, is in testing with many of the big indoor farms in the world. Now, we all want to bring our food closer to our major population centers, which is our cities, where most of the world is urbanized.
Yeah.
So it's really a great idea to, you know, take a parking lot and turn it into a vertical farm, you know, put up larger. It looks beautiful.
Yeah.
Okay.
Yeah.
But fundamentally, it's an economic and environmental disaster, in my humble opinion.
Why is that?
Why? Because you need a lot of energy to grow plants. Yeah. So instead of taking energy now from the sun, instead of growing a lettuce in California, where the sun is free, okay, and transporting it, and the carbon costs, the carbon load of transporting it to New York, okay, or you're growing it in a parking lot in New York, the environmental impact of bringing it from California is much less.
If it is in the parking lot, and then I don't know, there's LEDs powered by solar power, or there's water-based nutrition coming. Wouldn't that long term be a more sustainable way of doing it potentially?
Well, that's exactly where we come in.
Okay.
Because we say, okay, how could we make indoor vertical farming, what's called controlled environment agriculture? Okay, so that's the vertical farm in the parking lot. How can we make that more sustainable? Okay, and one of the ways you can make that more sustainable is to get the lettuce to grow faster, okay, and to grow bigger. And so what we're working on essentially are something which is used extensively in soil-based agriculture, which is biostimulation.
Right.
Okay, it's a very technical issue because obviously you cannot chuck bacteria into the water in a vertical farm because you don't want the water contaminated. Right. So what essentially we're introducing now, and it seems to be getting a lot of traction, are ways of stimulating growth using less energy, but doing that without bacteria. You could say it's like naturally doping the plants, you know. It's like a nootropic, a functional food, but for plants. And the whole aim of doing this is essentially to improve the economic sustainability of indoor farming. Yeah. So we are committed to this particular program, and we have a lot of very cutting edge research going on in this particular area. But you know, let me tell you one thing. Speaking as a farmer, we're a very strange bunch of people because it's hard to convince, even if a guy's got a sophisticated vertical farm, he's still a farmer. And it's very hard to convince farmers to change their practices. You know, even though it looks fantastic and looks very technical, it's very hard for them to convince us, hey, you take this particular biostimulant, you test it, oh no, our tanks are going to get contaminated, la 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 la, you know. So we struggle a lot, and we're just getting over the hump now with this, but it's taken us a lot of work. Plus, we have a similar program going on in North Carolina where we're using the same, we're using a similar biostimulant on soil. And there it's very important because not only is it about biostimulation, it's also about bioremediation. Bioremediation is, let us see how we can help in the transition of large-scale agriculture from pesticides, from fertilizers, from GMO. Let's see how we can move it to regenerative agriculture. And the one way is to be able to remediate the soil. And the algae are a very potent soil remediator. So to summarize it, our program in agriculture is essentially around how can we use algal technology to make agriculture more sustainable, more accessible to people, to be able to scale up agricultural methods like indoor farming, to ensure that instead of a high-end product, high-end greens, this becomes something which can be available at the 7-Eleven rather than in Whole Foods.
I think the regeneration part of the soil is super important. Like, I guess, you know, when you look at like birth and death of soil, you know, traditionally there used to be animals and grazing, then they die and they become, and then you've got, you know, the vegetables and the peelings all making, and then you've got worms coming in and eating it, and then regenerating the soil with their own fertilization method. So to have it completely organic and then having the algae to do that job, I guess, is what you're saying, right?
Yeah, you know, I think that's a very romantic view of agriculture, especially industrial, but I share it.
Right.
I mean, like, I don't see any reason why, with all the science and all the sophisticated technology we have at our disposal today, we are chucking hydrocarbon-based fertilizers, pesticides, which are downright dangerous, you know, on the soil. And I can give you so many examples. Potato, I'll never eat another industrial potato crisp again. You know, potato chip.
Why is that?
Because I have seen because I work with the companies that make them. We talk R&D, and I see how many herbicides and pesticides, etc., are on the peels, because we're trying to work on bioremediation of the potato peels, with anaerobic digester.
The skin is the most, carries a lot of nutrients in the skin, right?
Yeah, but I'm saying if you pick up a non-organic packet of potato crisps, I'm not saying it is possible that there are a whole range of herbicides and anti-mold agents on them, and actually the EU just banned the use of one of them. From October they will not be used in the EU.
Wow.
So what I'm trying to say is we're not an ideological company, but basically our idea is, hey, let's see if we can do it a bit better. Let's see if we can do it a bit bigger. Let's see if we can do it a bit cheaper. Let's see if we can do it away without killing animals or hurting the environment. And that what's interesting is that with the evil agro empires, and I won't mention names. The agro-industrial complex is the word. This message is starting to resonate a lot more. Because it's more positive message than, hey, you people are destroying the planet, which they may or may not be doing. I'm not going to comment on that.
For sure. So one of the things that we also spoke about was the infant nutrition, where you could see this going.
Yeah, we have a collaboration with one of the big infant and medical nutrition companies. And what I like about that, and why I probably mentioned it to you, is because historically Spirulina, the algae, the green microalgae, has been used in Africa around Lake Chad and in South America as a source of infant nutrition for thousands of years.
Okay.
It's extremely good, and there are studies which were conducted which show that giving kids Spirulina smoothies and that improves their school performance.
Yeah, so I have it in a smoothie, but generally I would put it into more like a green smoothie. And before you were talking about the taste. So in Africa, what were they doing because it's obviously quite a strong taste to it. How were were the babies just not chucking it out, like they didn't like it, or like what would they do to mask it, I guess?
Well, when the pandemic is over, I'll you can come and visit and taste fresh Spirulina.
Okay.
Fresh Spirulina has no taste.
Oh,
and
right.
if it tastes like anything, it tastes like perhaps very, very mild butter.
Okay. Wow.
So what you put in your smoothie is dried Spirulina.
Yeah.
Dried Spirulina has the problem of mild bacterial contamination, etc., which gives it that strange smell. Okay, that fishy smell.
Right.
What we've done is we've developed because the blue colorant, this blue, okay, it's extracted from Spirulina,
right,
which is a blue-green algae. So the green is what you put in your smoothie, basically. I mean, yeah. So what we've developed is when we extract the blue, we have a byproduct which is an odorless Spirulina. It's not colorless, it's odorless. And this is what we're incorporating into the burgers, into the plant-based meat, etc. And we have also doing quite a lot of research on trying to increase the protein levels, etc. Because currently the way that soy concentrate and pea isolate are made, it's a very industrial process.
Yeah.
And it's very energy intensive, and there are health issues, And so what we're trying to do is, okay, can we increase the protein content in a much more natural and gentle way? And have a high protein powder, and actually that's in testing in a few food production facilities at the moment.
And we spoke about this hybrid model of like mixing cell-based with plant-based, like maybe mushrooms into a burger. Is that where you see, like, at least for the short term, that taking off before it goes fully, fledged into cell-based meat?
I think it's happening. It's happening. It's happening on a industrial scale. For example, I think it's very. I mean, I know you're not allowed to. You shouldn't mention the Tyson word on a call like this. I mean, Tyson. have a not a stellar record in the way that they manage the food chain, and especially the way they manage our fellow living creatures upon this earth. But they introduced a mixture of plant-based and real meat, you know. And you can say a lot of things about it, but that's reducitarian. That means less animals are going to be killed. And I think that that's only the beginning of this trend. What we're fascinated with, because we're obviously at the cutting edge of R&D, at least I hope we are, is can you, for example, make hybrid food? In other words, cruelty-free meat mixed together with plant-based meat, mixed together with mushroom, grown in new ways, new bioreactors, and I can show you one of the new bioreactors which we're developing. You know, can you make new kinds of food? Because I don't think that the future of food is going to be a steak grown in a big tank. You know, I think we're wrong.
Yeah.
I think the future of food are things which both you and myself haven't even thought about. Okay, and we're always trying to challenge ourselves and say, okay, we are going to be making, for example, a sushi. Okay, the sushi consists of shrimp cells, which are grown in a bioreactor, but all the gas exchange is done with algae. And the bioreactor also has mycelia, healthy mycelia, maitake in this case, which are, you know, the mushrooms are growing together with the shrimp cells. Okay. And the algae are doing the gas exchange, etc., etc. What you come up with is a paste. And that particular paste is mostly shrimp, tastes like shrimp. At least I taste it, it tastes like shrimp. And then we print that, we're going to print that on with our 3D printer. Okay. So you can have a shrimp hybrid sushi, you know, with completely cruelty-free, tastes like shrimp, or tastes pretty close to shrimp, but with a maitake edge. You know, I think I'm watching too much food TV in the US because like, the edge, that tastes good. You know? So, I'm not gonna lick my lips a little bit. Well, we're gonna do that kind of. That's hybrid food.
Okay, great. So let's take some time now, and maybe we can start doing the tour now and meet some of your colleagues who are working on this stuff. So yeah, let's move to that, and we'll start to show this now. So I'd like to welcome Katie Speer, one of Leonard's colleagues. So hi, Katie, how are you?
Hi, great. Thanks for asking. So I studied environmental science at Loyola University in Chicago, and I also studied film and digital media.
Oh, nice.
And basically why I did the two was that I wanted to intersect science and understanding it and communicating it to people so they would have a stake in it to care about. And I found that here we're doing a lot of different innovative things, working with the algae and all the different way it applies, but we also really want to have a use and a real role in the world where people can understand it and use it and improve their lives and improve the planet and the climate all along.
Yeah, awesome. So you said that you studied environmental science, is that right?
Yes.
And so when did you graduate?
I graduated in 2018, so almost like 2 years out, and I started out doing renewable energy, just replacing and retrofitting buildings for more energy efficiency, and just realized that I hated that. And it was just not enough in the middle of it, and it was too much just replacing things and getting people discounts, and they didn't really care. And then coming here and really working right on it and getting into the physical science and understanding it, and really producing something that would matter is what drew me to it.
Great, awesome. So thanks very much for coming to talk to us.
Thank you.
Welcome to our Algae Digester Lab. This is the pilot production plant, part of our operations. And so what you see on this side are photobioreactors. These are tubes inside which we grow algae. And what we are doing at the moment is a whole series of experiments to work out the link between food waste and food. And the way we do that is we take food waste and we digest it in an anaerobic digester, and then we use the what comes out of that to grow algae, and then we make other things like biostimulants, etc. from it. This is a very, very...
So Len, for your test, what are you using for food waste at the moment in those tubes?
At the moment, and we just go down and look at the anaerobic digester. At the moment, we use essentially the food waste of the building. This is a large building. There are a lot of companies, there are indoor farms, etc. And so that food waste is mixed up, is chopped up, and is put into this tube. And over a few days, it travels through the tube, and eventually we get solids and liquids. And it's those liquids that we then use with special algae to clean the liquids, and then we can use those liquids for other things. For example, like cell culture in our cell culture lab, which we will shortly see. So this is the anaerobic digester, and this is the baby anaerobic digester. And we're going to see the big anaerobic digester, which we are busy getting operational in partnership with Bubbly Dynamics, the owners of this building. And if you look on this side, you can see a large industrial dryer. What we're doing here is we are doing the final step of the process. And if you come with me to look at what's happening at this very moment, and I apologize for it being so noisy, what we have drying on this belt at the moment is a mixture of mycelial or mushroom extracts and a range of algae extracts which we have produced. This is going to be used for vegan yogurt and for nootropic chocolates, all vegan. So here you have an actual example of a test production run, and you're very fortunate to be here today because we have everything's running today.
Awesome.
Do you have any other questions about our algae digester lab?
So what else can you put through that big sort of dryer?
The dryer is mainly used, it's big, but it's still a test scale dryer.
Right.
It's mainly used to dry algae extracts.
Okay.
Know. But now because we're starting to do mushroom cell culture using waste, etc. We're also doing mushroom or mycelial extracts.
Right. So once it's dried, you could potentially use that in the powdered form in supplements and things like that as well, right?
Yes. In fact, if we look, I can perhaps pick up some powder here. You can see that powder.
Yeah.
So that is mycelial and algal extract.
Yeah.
And I'm going to eat it. It's tasty.
What does it taste of?
Well, because it's a mushroom extract, there's a slight bitterness and a slight chocolatey taste to it. I think it's going to work very well in our single origin vegan chocolate, which we're producing in cooperation with a chocolatier in the building.
Nice. So would you not need to mix that with, the cocoa beans, or would it still be mixed with cocoa beans if you're making chocolate?
Yeah, this is just a chocolate ingredient.
Okay,
in fact,
right.
if you come to my office, I'm going to show you some chocolate, which I would have given you if you'd come to visit us.
You can always post it to me.
So over here we have essentially large-scale production machinery. These are titanium membranes. Over there you can see in the corner we have freeze dryers. Here we have a small laboratory scale spray dryer. So what we're trying to do here, as I explained in our earlier discussion, is essentially we're trying to emulate the large scale production of plant-based alternative protein, cruelty-free food. And now we can carry on, and we can visit. We can look at the digester, and then we can visit our cell culture lab. So as you can see, when we walk through the building, this used to be an old pork processing plant. And you can still see the remains of that. If you look at the roof and the walls, this is where the smoke houses were. And John Edel, the owner of the building, has succeeded essentially in preserving all these vestiges of the its industrial heritage of this building.
Yeah, and like you say, it is quite amazing now. It's turned into a plant-based, future-facing factory with karma going back around now.
Yes, and if you look outside here, we won't go outside. You can see first you can see our barbecue where we often do testings of plant-based burgers, and then you can see a tube.
Right.
That tube is the anaerobic digester. So that's a big version of what we saw. And behind that, you can see the city of Chicago, the Willis, or what used to be called Sears Tower, and the skyline of Chicago. And that digester is one of the biggest digesters in an urban area. And when it has a second tube next to it, it can basically take all the restaurant and food waste and all the secondary waste of food manufacturing from the Chicago area and turn it into something of value. And that's basically, a lot of our research turns around that. And where it perhaps becomes the most exciting is in our, what we call the Seeker Lab, which is the circular economy, cellular agriculture laboratory. And we're going to go inside, and you can see our masked wonder, Alex, who is our head of analytical chemistry. And we just give you a brief introduction to this laboratory. Essentially, this is where we do our cell culture and our analytical work. And it's a fully equipped laboratory in terms of having everything that's required to do mammalian, mycelial, or mushroom, insect, and other forms of cell culture. And so perhaps we can go around to Alex and ask him what he's up to.
Yeah, you'll have to talk on my behalf then, because you won't be able to hear me. But yeah, if you can tell him hi, Alex, it'd be great to know what he's up to at the moment.
Right now, I'm kind of getting probe for our mass spec. It's just a way to analyze solid samples very quickly on a mass spectrometer. But generally, what I do is operate with HPLC and mass spec systems, which have a new application. I can develop a new method for it, and that's how I spend most of my time.
Yeah, so Len, I have no clue what he just said because I can't hear him with his mask on.
Okay,
but maybe
you can't be heard. So you're out of it, right, Alex? Nice knowing you, Alex. Okay. So let's do something exciting now. Let me show. Now, perhaps when we're at the end, we can give Alex my earpods and he can speak, and then I'll sterilize them. So what you have here, this is called an incubator. And what we're doing here is we're doing mycelial cell culture. So we take our algae extract and we use them to see if we can get cells, be they mycelial or mushroom or animal or anything like that, to grow faster. And so that is it's a tedious job. All R&D is, and it takes us a while. But because we use these extracts, we actually can grow things quite quickly. And if you go into the vestibule over here, this is our pride and joy. This is the cell culture section, and over here we have a sorry, we cannot go in because of this. One of our team is working in sterile conditions, and what we're doing in there is we're basically working on growing shrimp using algae extracts. And this is a kind of hybrid food I was talking about, where we would be doing shrimp mycelia culture together. And next door we have another clean room which is devoted to our mycelial work. We're very interested in mushrooms because essentially mushrooms and algae are the two foundations of the of life on the planet, fungi and algae. So we're trying to work on basically hybrid food using those two. And here you can have a very nice view of the digester.
Yeah.
From
So
closer up.
effectively, everything in that yard is yours, and you have access to do that at industrial scale. And like you said, if you got one of those extra ones, you could cater for all the restaurants in Chicago.
The actual digester belongs to the building, this big thing.
Right.
But it hasn't been operational for yet for financial reasons, and we feel that we can contribute to making the business case for it by finding innovative ways of creating value. I think I could give you a whole lecture on anaerobic digestion, but it's a very controversial issue because it generates CO2, and if it's not done properly. And the biggest problems are economics. And basically what we're working on is, can you take food waste and create something of sufficient value that it becomes economically interesting to take the food waste of a city and turn it into something rather than dumping it into a landfill.
Right.
And
is there technologies out there that will help reduce the CO2 in that process?
Yes, I mean, I think, for example, we take the CO2 from the brewery downstairs and we use it to grow algae. We won't be visiting the brewery today because of it's a bit difficult to get around the building with COVID-19 issues. So there are ways that you can use. You can use everything from an anaerobic digestion with algae. And the combination of anaerobic digestion and algae is very, very promising. Where we're going to go now is our other lab, which we're building out as a food innovation lab. That's a bit messy. It's essentially where we have our large-scale cell culture units, and we also do our agricultural R&D in this area. So what we have here are robotic cell culture units. These are very big, and they're essentially designed for production. And we're working on a concept that one day that we will actually have a pop-up restaurant here where the meat will be produced in these particular machines. So we have ideas. And we have other various bioreactors which are operational. And over here is where our agriculture specialist works. And you can see we're actually running an experiment to do some of our agricultural R&D. The large-scale work is done obviously in farms, in experimental farms in North Carolina. But so here you can see that we have lettuce that we have grown, some of it with our algae extract and some of it without. And what we're doing here is a shelf life test, where we are keeping it at ambient temperature, and we're trying to see, we're seeing how, we are trying to show something which we have proved already, is that using these algae extracts improves the shelf life of lettuce, which is very important for the economic viability of indoor farming. That means inspecting it, and you actually see a difference in the moisture content, and the amount of transpiration already. So looking good. And I don't know if we're going to lose signal or not, but these are areas which we are building out. I first want to offer you I want to offer you your chocolate. This is our break room. And so there you go. These are the chocolates I was talking about.
Oh, lovely.
And in fact, here's the chocolatier himself, Jay.
Right. Okay. Hi there.
Okay. And if you were here, you would get these chocolates. These chocolates are with spirulina, and they have our blue phycocyanin topping. And Jay will be making chocolates with that mushroom and algae extract that I showed you.
Awesome.
Yeah, and then this is where we keep some of our samples. Here is there's a kombucha brewer in the building.
Oh yeah.
And he makes a kombucha which has our blue phycocyanin in it, and it's becoming quite popular.
Fantastic.
And these are our extracts. Okay. So we can visit what we're building at the moment here as a mycology lab, and it is where our mushroom specialists work, and you can see this kind of research does require quite sophisticated technology, extraction technology, and on this side, here's a wave bioreactor, which they are going to inoculate. We are doing some work on medical applications of mushrooms, and they're going to be inoculating that, I suppose, in the course of today. And what else are they doing here? Well, I don't know. I'm sure it's good. So essentially, we are focusing more and more on the whole idea of hybrid food, mycelia, algae, etc. Especially now that our large-scale production of colourant and algae plant protein is being done at our facility in Utah. So that's a little tour of our facility, and I hope you enjoyed it.
Yeah, so that was amazing. So just one last question. If you were going to put a timeline on when cell-based meat will be ready, or and affordable, even if you were to mix this hybrid model with mushrooms and the mushroom extracts, when do you think that will get to become quite popular with the general public?
I don't think that the problem is a question of demand. I think it's a question exclusively of supply. I think that people will accept it. And if you read, I sent you an article today in the New York Times, which explains the very clear philosophical basis of there should be no distinction between meat which comes from a live animal and meat which is grown in a bioreactor. I think that people are overplaying any resistance from the public. The main problem is that of supply and the economics of large-scale production. Which once we've got the science right, we have to get the economics right. And we feel that we're making a small contribution to that by trying to see if there are interim steps before we're going to be able to grow. Maybe we'll be growing a steak in 50 years, but we're not going to be doing it tomorrow. And what can we do tomorrow to reduce the amount of animals that are killed? And one way we can do that is to make new kinds of food, which would be small amounts of animal cells together with plant cells, together with mycelial cells. And that to me is the future of food.
Yeah. So yeah, thank you so much for showing me around today. It's amazing what you've got there. So many things that you're working on, and yeah, great facilities actually. And yeah, I wish you the best of luck.
Thank you so much, and I hope that you can come and visit, and we'll grill you a plant-based burger. We'll give you chocolate.
Yeah, that'll be awesome. It's been a while since I was in Chicago, so it'll be great to come back again.
Excellent. Thank you so much for having us.
Yeah, thank you, Len. Speak soon.
Thank you.
Cheers. Bye.
Bye-bye.